Hello everyone, welcome to today's lectures. I will be a teaching assistant for today's lecture and the lecture next week. Um, Before we start the lecture today, I will briefly introduce myself. I'm Wei, a PhD student in the IFES graduate school um, at TU Darmstadt, and this graduate school is led by our Professor Arina Goodwich. And currently, I'm working with Dr. Stephen Eggers on different projects such as test generation evaluation and cross-lingual representations. Okay, today we will talk about how to use Pythons to make some basic analysis for natural languages. Um, Probably many of you are already familiar with Python, um, which is a great programming language because you can always find many useful resources like documents and open source libraries in the internet. And nowadays with Python, basically you can do everything. Uh, for example, you can use Python to make NLP projects or computer vision projects or any other projects that are related to artificial intelligence. And if you want to be an expert in this course, I would highly recommend you to practice your coding skills every week when time permits. And also it's good to review the previous slides and you have times. Um, and of course, the lecture cannot capture everything, cannot cover everything. So if you want to learn more in a very detailed ways, and you can go to the chapter 1 from the NLTK website, and there and from which you can learn every details about these lectures. Finally, please feel free to ask us any questions in the forums or just contact us by emails. Let's start with the NLTKs. NLTK is a very powerful open source library written in Python, and which includes many datasets and provides features to solve NLP problems. For example, you can use NLTKs to do task classifications and to generate many linguistic features like syntactic features and part-of-speech tags from the sentences. To use these features, you have to import NLTK at first and download all the resources provided in NLTKs by running this one-line code. After that, if you are interested in accessing some datasets provided in NLTKs, and you can just import the data modules called nltk.book, and then you can get two corpus, test 1 and test 2, where you can see two titles of two corpus in the following. Now, if you are interested in finding sentences in the corpus test ones, which include your specified words, most of us, or some other words you want to search, with NLTK, you just have to write one-line code only, then you can get the results you want. Here you can see, you find 11 sentences which include most of us. That is pretty easy job, right? Because with NLTKs, many tasks like this become very easy to solve. Okay. Now, if you want to find some words in test 1 and test 2 corpus that have similar meaning to your specified words, like most of us here, and you just have to write a one-line code like this, and you can get the results. as you can see here, the resulting words found in test 1 and test 2 corpus are pretty different. This is normal because the authors in these two corpus probably choose different words to express the meanings similar to your specified words, right? Okay, let's look at the organization of this course. Basically, this course will teach you how to use Pythons to solve NLP problems. Um, in these lectures, we will see some basic usage of Python and NLTKs. In the future lectures, you will see how to use them to solve high-level NLP problems, for example, task classifications and information extractions, and so on. Notice that deep learning techniques are not covered in this course, but this course would be a very good preparations for the deep learning course next year. The interesting thing is, computer is a digital device, right? So it's only can understand the numbers instead of high-level signals like text, speech, and images. If you want a computer to understand the natural language, it's better to find the transformations between natural language and the numbers. For example, you can use ASCII code to translate a character into numbers, right? And also you can find an encoder which can translate text, into a vectors, like word embeddings, if you know what I'm saying. Now we know a computer somehow can understand the natural languages, but languages is indeed very complicated. For example, many articles probably have different topics, and some articles may be too long, and this has some disambiguities, such that even for humans are very difficult to understand. So it's interesting to ask a computer some questions and to see if a computer is really understand something from the test. For example, here we have 3 articles. On the left side, we see the article is very technical, and the article in the middle is about news, and the article on the right side is about cookies. So we can ask a computer if it can classify these articles into correct labels. Now we know languages are complicated to understand even for humans. But the good news is we have many open source libraries like NLTKs, which can help us to solve some NLP problems. And maybe some of you have experience with NLTKs already. If not, I would highly recommend you to play it around. And you can always find many great resources, documents, especially documents, and to help you understand the details. Let's take a look at real examples to show how to use NLTKs to make some basic analysis for tests. In these examples, we use the corpus provided, data corpus provided in NLTKs, and we just load the data modules in NLTK. Then we will find the following 9 test corpus are automatically loaded. Then we can ask our questions, and how many words are in one specific corpus. For example, we write one line code like this, and we can see there are roughly 40,000 words in the test 3 corpus. And notice that every single punctuations will be treated as a single word, and where and also there are some words that are repeated many times in the corpus, and we call these words are tokens. Okay, and maybe we will ask another questions and to build vocabularies and to show how many distinct words are in that corpus, right? And maybe we also want to know each word, how many times each word appear in that corpus as well. So, for example, we have a sentence to be or not to be, and we can create vocabularies for this sentence. And the result is like we have four distinct words, and for example, the word to appears twice in that sentence, and the word not appear once in that sentence, right? And then how to count distinct words? Without Pythons, you have to create an empty dictionaries, then make iterations over every single word in the sentence. And you check if the word is already in that vocabularies. If not, you put that word into the vocabularies and make the counter of that word to be 1. If the word already in that vocabularies, and you just update the counter of that words, that's it. But you see, you have a lot of you have to program a little bit by yourself and without the use of Python. But with Pythons, everything gets very easy to be done. For example, you just write one line code like this, and you will get all the distinct tokens, and all the duplicated tokens will be automatically removed. So basically, you can use Pythons to do a lot of things like this in 1 second. Now we know the number of distinct words and the total number of words in the test corpus 3. And in these examples, you can see the test corpus 3 is very easy to understand because the writers of corpus 3s only use vocabularies with a size of about 3,000 words. So yeah, then we call then sometimes we want to measure the difficulty of test understanding for a corpus more correctly. So the measures, which is called the lexical diversities, and basically we just make the number of distinct words divided by the total number of the words. And we call this type token ratios, and sometimes we can use this measure to judge the language ability of the speakers and the writers. Of course, you can repeat this line of code many times to get lexical diversities for other test corpus. To avoid the code repetitions, you can just define some functions, something like this. More concretely, you have to make a def as a keyword in the first place for the function definitions, and followed by the name of the functions and the names of parameters. And you have to make 4 spaces before making any specific codings here. And if you want to get something from that functions, you have to put a keyword return here. And in these examples, you will return the lexical diversities calculated by this line of code. And as long as you have defined functions and you can invoke it, by specifying the name of the functions and the values of the parameters. Then you will get the results. Let's see the different lexical diversities across article genres. For example, it's not surprising to see the scientific, like mathematics articles, have a very low lexical diversities, while some other articles like humor and science fictions have a relative high diversities. Okay, let's have a very small exercise, and the problem is you have to count the proportion of definite and indefinite articles for a given test corpus in whatever language you prefer, and yeah, you can take this as a homework and start with using Python to program a little bit. Now let's look into how to use Python to process tests. For example, we have a sentence call me emails, and in Python, usually we use a list of tokens to store this sentence, and this must be surrounded by square brackets in Python. And also we can use previous defined functions to get the lexical diversity in this sentence. The result is 1 because the number of distinct tokens is equal to the total number of words in this sentence. And notice that list is a very important structures in test processings. So what else we can do with list structures in Python? First, we can calculate the number of words in a list, and also we can combine different lists by making plus operators between different lists. As a result, we just add the second list to the end of the first list. Also, we can add a particular words to the end of the list, and also we can access a particular word by its positions, and also we can do the other way around and to get the index of a particular word, and also we can access a sublist by specifying a range of the index. But be careful, the index is from 0 instead of 1. So if you specify an index of 2, and then you will get the third word in the list. Of course, you have different ways to access sublists, and you don't have to specify all the indices left or right to the column. And for example, here, if you can just input 1 and the columns, and you will get the words from the second position to the final position. And you can use Python to do a lot of other things. For example, you can sort a list using Python, and for example here you can sort the board, Sir, and the Robins, and using sorted functions. And notice that the default parameter for the sorted algorithms is making ascending order for a given list. And you'll get the results like this, and the Robin, Sir, and the board. And notice that the board is is on the right side to the Robin and the Sir, because the computer will first translate all the characters into ASCII code, and in the ASCII code, you will see the lowercase the character has a much higher number than the uppercase characters. And if you want to reuse something during programming, um, creating variables give you very good opportunity to do so. In this case, you have to specify the variable name, assignment operators, and of course the values. And notice that you cannot name variables with resolved words in Python. For example, you cannot name variables with def if not an input, and so on. And of course, you can just assign strings directly to the variables, and you can access to some characters in the strings and by index, and also some sub characters, a range of characters in the strings, and also you can make some conversions between list and strings. For example, you can use join functions to merge a list of tokens into strings, and you can do the other way around as well. You can split strings into a list of tokens. Now let's see how to use NLTK to make very basic statistics over a given corpus. Maybe we are interested in finding most frequent words in a given corpus. Frequent words are very important because probably they are very informative about test and the genres, or maybe some other reasons we want to find them. And but how do we find these frequent words, and how can count these frequencies of these words? And with NLTKs, things get very easy to be done. For example, we can just invoke the frequency distribution functions by given test1 corpus as the input, and we will get a dictionary with all the words and their frequencies in the test1 corpus. Then if you are interested in the frequency of particular words, and then you can just specify that words you want to find its frequencies. And also you can get the top K most frequent words by invoking the most common functions, and you will get the results in a second. Now let's see if frequent words are really informative and helpful to test understandings. To do so, we can plot accumulative distributions over these frequent words. And please notice that these frequent words are the ones that are pronouns and the punctuations. So in a sense, you cannot learn something very specific about the content using these frequent words, right? And indeed, you see that nearly 50% of the test is made by these frequent words. So these words are not informative at all to test understandings. Then how about the real words? The answer is no. The real word is also not informative at all, because these words that occur only once or very little time in a given corpus, and so you also cannot know anything useful, anything meaningful about the content. So neither frequent and infrequent words are informative. Then our question is, how about long words, right? And we can write a piece of code like this, and we make iterations over all the words found in test corpus ones, and then we can get all the words whose length is longer than 15. Then we will get the words below. You can see these words are the ones that are very emotional, so you cannot tell very specific meanings. You cannot tell something very specific about the content, right? So if we wanted to find informative words in a given corpus, probably we need to find intersection between long words and frequent words. And to do so, we can write a piece of code like this. Then we will get the words that are both long and frequent in a given corpus. Then we will find words like questions, computer, football, watching, listening, and so on. And from these words, we still cannot get the full picture of the stories, right? But in a sense, we can know something very specific about the content. Now we will introduce a new concept, n-grams. For example, here we have a sentence, more is said than done, which is a list of 5 unigrams, where unigrams means every grams has a size of 1, and in this case, semantics of every single words are treated independently. So if you are interested in semantic compositions, over 2 words, you have to create bigrams, where bigrams means every gram has a size of 2, and in this case, you will get the first bigrams more in is, and the second bigrams is in the said, and so on and so forth. And of course, you can scale this to n-grams, and for example, if you are interested in trigrams and character levels, and you will get one of the trigrams ALL in hello. And if you are interested in bigrams at word levels, and you can get one of the bigrams be or in a sentence of to be or not to be. And sometimes we can use bigrams to express collocations in a given corpus. Where the collocation means a sequence of words that occur together very often. For example, people usually say strong words instead of strong T instead of powerful T. So with NLT case, we can do this task very easy. And for example, we can find the United States, fellow citizens, federal government in a given in the test FOLT corpus. Now let's see how to use Python to write code in a more efficient way. For example, if we want to know length of every single word in a given corpus, in Python, so we only need to write one line code. Since the result is about a list of lengths, so we can create a nested loop functions within a list. But in other programming languages like Java, you cannot use nested functions, so you have to write them down completely yourself and in 3 lines. And if you have some condition logic in mind, you can also add them into a nested functions in the same line. To complete the condition logic, you have to choose one of these relational operators to compare the relation between 2 numerical values. And in addition, you can choose one of these word operators, or we call it string operators. For example, you can check if the strings starts with a particular characters or end with a particular characters, or is this particular characters is contained inside the strings, and so on and so forth. Now let's look into the examples that use condition logics. For example, probably we're only interested in finding words that end with ableness in a given corpus, or maybe we're just interested in words that contains GNT, or maybe we're just interested in finding digital numbers in a given corpus. So in Python, we we can write the code in a very simple ways because we can use the nested logic functions within a list, which is a very effective ways compared to other programming languages. Now we are looking to the distinct words where we previously we defined vocabularies, which is a list of distinct words, and we use set operators over a given corpus to produce a list of distinct words. But the resulting dictionary is not very clean because the upper and the lowercase words are treated as different words. Also, numbers and punctuations are counted. Now we want to find a clean version of vocabularies, so we want to ignore the word cases and ignore numbers and the punctuations. In Python, we can write everything in one line. First, we make iterations over a word in a given corpus. Then we lowercase everything. Then we check if this F word is using alphabet only. And then we use set operators over these resulting words to remove duplicates. Finally, we will get a clean version of vocabulary. Now we look into the complex conditions, which combines many simple conditions. For example, if C is a condition, then not C is also a condition. In this case, we can combine two conditions, C and not C's, using if and else. And also, if we have two conditions, C and D in parallels, we can combine them in different ways. For example, we can combine C and D with and then the complex condition will get true if both C and D are true. And also, we can combine C and D with or. Then this complex condition will get true if one of C and D is true. Then we can use these conditional expressions to control whether code should be executed. And in these examples, the print functions will be executed when the word length is less than 5. Now we look into the loop functions and where we can use the loop to iterate every single word in a given list. Also, we can combine loop function with conditions. In these examples, only word and with a particular character L will be printed. Now we are looking to a full condition case. Where we have the else if and the else, which is to control the executions when if fails. In these examples, first we iterate every tokens in the sentence 1, then we check if the tokens is a lowercase. If not, then we go to the else if step to check if the token is a title case. If not, then we go to the else step to print this token. Now let's see why test analysis is very important in the daily life, because we can develop many useful NLP applications. First, we can make topic and generic classifications. For example, we can distinguish articles from different sources, and also we can automatically label documents into different categories. And second, we can identify the authorships to see who wrote these articles. And also we can check the test readabilities and to see whether the test is readable for children. And also we can develop some applications to help people in writings, for example, detecting some grammatic errors. Now we will review what we learned in these lectures. Basically, we know how to use Python and NLTK to do some very basic analysis for tests. We know how to build our vocabularies and how to find frequent words, real words, and long words. And we also introduce the concept of n-grams, and we see the bigrams can be expressed as collocations, and we also know how to measure the lexical diversities for a given corpus. About programming, we know how to define and use functions, and how to operate the string and the list, and we know how to use and define conditions and the looping. For the lecture next week, and I will highly recommend you to review the previous lectures, and please finish your homework on time. And and if you have time, so you can read the chapter 2 from the NLTK website. And yeah, I think that's all for today's lectures. And thank you very much for coming today, and see you next week. Bye.